We are live. Okay, so today, first of all, there's a thing called synthetic substitution. Date, it is 9:30. So today what we want to do is we want to learn how to divide by synthetic division. And then we're going to talk about the remainder with synthetic substitution. Okay, now I want to show you something out of our journal, and I think it should make sense. Synthetic substitution is going to be used to find the remainder. Okay, write that down. Synthetic substitution is going to be used to find the remainder. The reason it's important, and I'm going to show you what this is in a minute. The reason it's important is if the remainder is 0, then what you are dividing by is a factor. Now I'm going to give you more information on this, but I'll let you write that down. And before we do anything, let me just give you the easy example again. Okay? I'll wait for you to get caught up. So I like the example 4 goes into 20. 4 goes into 20 how many times? Well, there you go. I did it myself, didn't I? So 4 goes into 20 how many times? 5, right? Is there a remainder? Is there a remainder? No, right? 4 goes into 20 evenly, so 5 is a factor because the remainder would be 0. Everybody agree with that? So if it goes in evenly, it would have a remainder of 0, okay? Does 4 go into 21? No. Because we'd have a remainder of 1, right? So the remainder theorem says if it goes in evenly, you'd have a remainder of 0, right? So I'm going to go back to one of our problems in our homework today because they're from last night. So if I go back to this one, right there, number 3. So if I looked at number 3 and I divided 4x plus 1 into this, I got a remainder of 0. Because it's a remainder of 0, then 4x, so then 4x plus 1 is a factor. Okay, it goes in evenly. Remainder of 0, it's a factor, okay? So, synthetic substitution can be used to help us find this, okay? So if x minus a equals 0, and p of a equals 0, write this down, I'll show you what this means, then x minus a is a factor, okay? Let me show you an example. I have p of x, that's my polynomial. They use p of x, polynomial. P of x is equal to x cubed plus 4x squared plus 6x plus 4. And I want to divide that by x plus 2. Okay? I gotta see this sometimes. You gotta listen. Now listen, put that phone away. Say this several times. Okay? Now, if I change the question to this, listen. Is x plus 2 a factor? Does x plus 2 go on this evenly? When I divide x plus 2, will I get a remainder of 0? We can divide it. It's a pain, isn't it? Right? If I plug in negative 2 into this, I'll get the remainder. Luke, are you listening? That phone away. It's time for me to start taking phones. Next phone, take it away. Take it away. It's going to be mine. Put your phones away. No more phones. I promise to take it away. Keep it till the end of the period. Or longer. Okay? Pay attention. What a good guy. I'll put it on my desk and I'll give it to you later. Okay?
Why do you do that?
Because he just knows. Kevin doesn't want to be tempted. Okay, so listen. So, is x plus 2 a factor? Okay? Meaning, okay, is x plus 2 a factor? So, if we were to divide this, which is what we did yesterday, long division, divide this into this, and if we got an answer of 0, then it'd be a factor, right? So this synthetic substitution says there's a faster way to do it. If all we care about is the remainder, not the answer, but the remainder, then if we plug in negative 2 into the x, and we get an answer of 0, it's a factor. Now we won't have the answer to the division, we'll just get the remainder. Does that make sense? If we get the remainder of 0, we can say, yes, it's a factor. I'll say it again. If I plug in negative 2 into this, and I get an answer of 0, this is a factor. We don't know what the answer is, but we do know it goes in evenly. Does that make sense? So synthetic substitution. Substitute. So if I were to take up here, and I have x plus 2 equals 0, or x equals negative 2. I'm going to plug negative 2 in for x. Okay, let's see what happens. So I take negative 2. I'm going to go, okay, negative 2 cubed plus 4 times negative 2 squared plus 6 times negative 2 plus 4. I'm going to use my calculator to help me out. That's a lot. Okay, so let's go ahead and use my calculator. I'm going to go, okay, parentheses, negative 2 to the third power plus 4 times my negative 2 squared plus 6 times negative 2 plus 4. And I get an answer of 0. So here's what I know. I didn't divide it. I didn't have to do all that big work, but I know this, that x plus 2 goes in evenly. So yes, that's a factor. Now, let's look at example 1. Is x minus 2 a factor of 4x squared minus 4x plus 4? I don't know. Let's plug in. Yes, Fernando. What? Sure. So if I plug in x equals 2, right? Because you solve plus 2, right? Plug in 2. I could go 4, plug in 2 times 2 squared minus 4 times 2 plus 1. And I'm going to get 4 times 2 is, so just use my calculator actually, probably 4 times 2. What'd you get?
9.
You got 9, okay, awesome. Probably right. Yeah, I get 9, okay. So if I were to divide this, we should get a remainder of 9. You guys agree with that? If we do divide this, so like yesterday we went x minus 2 into 4x squared minus 4x plus 1. Okay, so x goes into 4x times. We have a 4x minus 8. Remember how we did this yesterday? And then I subtracted, but I really don't want to subtract. I add a negative, and then I get a 4x. I bring down the 1. X goes into 4x 4 times, a positive 4 times. 4 times 4 times x is 4x. 4 times negative 2 is a negative 8. I don't really subtract because I like to add a negative. That makes it better for me. And what's my remainder? 9. Okay? So, synthetic substitution. You plug it in. If you plug it in, it tells you the remainder. Okay? Why is that important? Because we want to know if it's a factor. Say it again. If you plug it in, you'll get the remainder. If you get the remainder, it tells you if it's a factor. If it's 0, right? If it's 0, anything else, it's just not a factor. Okay? Now, I've been keeping a good secret from you. So in Luke, synthetic division does not work on everything, okay? But it does work. It's really a cool way to divide. Synthetic division is a nice little trick, but it only works with x plus some number or x minus some number. That's the only works for that. Okay, so here's how synthetic division works. Okay, so when we do synthetic division, first of all, everything's backwards, everything's upside down, and the variables are invisible. So we're going to make the x's invisible. Okay, so that 4 x to the 4th, the x to the 4th is invisible. Minus 2x cubed, x cubed is invisible. 1x squared, that's invisible. Minus 3x, x is invisible. Okay, so here's what we do. I want you to write this. Write an upside down division sign. Upside down. Start right there. Okay. We're going to put -3 here because we're going to take the opposite, because if you set it equal to 0, so you take the opposite. X plus 3, I'll put -3. If this had been a minus, it would be plus. Okay, so the opposite. It's got to be the opposite. This is easier, guys. Trust me. And it's actually really easy. Now, the x's are invisible, right? The x's are invisible, so I'm going to write 4, -2, 1, because I got a 1 right there, -3, and 4. Okay? So I'm going to do 3 things so far. 3 things I did is upside down division sign. Second thing I did is I took the opposite of that, right? And the third thing I did is I put down my numbers. X's are invisible. Okay? They're still there, but they're invisible. Okay? Now I'm going to draw another line. And this line, right underneath it, I like to call the add line. Okay, I like to call that the add line. And then right underneath the 4, way down here, I put a box. That's where my remainder goes. Okay, so here's how you set it up. We haven't done it yet. It's actually easier. It doesn't seem like it. It's easier because I keep explaining, but all you do is this. Upside down division, opposite, so +3, -3. The numbers go in without the x's. X's are invisible. Now, let's start doing this. So the very first step is an important step. You just bring down the first term. We're going to just bring down the 4. Just bring it down, straight down. Put an arrow through there so you don't put any numbers there, okay? And we're going to put down the 4, okay? Now, just like multiplication and division, we're going to multiply. Okay, so I bring down the first term. I'm going to multiply. And I'm going to put that right here. I'm going to put -12 right there. And then I add. -2 plus a -12 makes a -14. And then I multiply. -3 times -14, I don't know, that's what calculus made for. I get a +42. And then I add.
43.
Yep.
So smart.
And then I multiply. I don't know, 3 times 43 is -129.
That means 132.
Then I add, that's right, I get 132. Told you all we're doing today is multiplying and adding, that's it.
Easy, bro.
It is easy. You guys agree? Nope, I'm not.
Nope,
Nope, I'm not. Then you multiply.
This is not gonna be on the test. Let's be honest.
This is on the test, and it's not going to be that hard. And I get a 396th. And then I add,
400.
I get 400. Okay, now my answer
400.
is there.
Oh, that's the answer?
But bring the x's back, okay?
400
So the answer's there. Now listen. Okay, the answer's there. The answer's going to be, and we're going to write it in a second, 4x cubed minus 14x squared plus 43x minus 132, and that's my remainder, which will go 400 over what we divided by. Now the x's were invisible. Let's bring the x's back. There's always going to be one less power. One less power because I really did invisibly divide by x. So it is going to be one less power because I invisibly divided by an x. Okay? So let's bring the x's back in the answer. So the answer is just this. Okay? So our answer is going to be right here. Here's our answer, but let's put it together with x's. So my answer is 4x cubed minus 14x squared plus 43x minus 132 plus my 400 over what I divided by, which is x plus 3. A lot easier than yesterday, right? But it only works if it's x plus or minus some number, okay? So on number 4, let's do example 4. Yeah, do it, but I'm going to make sure you one trick, make sure you go as 0x to the 4th power, okay? So I'll let you do it. 5, 4, oops, 0, I'm sorry. 5, 0, 3, 4, negative 4, 1.
It makes so much sense next to the zero out of anywhere.
Right, great question. And in fact, I'm going to explain the 0 in a second, okay?
0 or 4?
This is 0. I'll show you.
Why is it? Wow.
I'm going to explain. It'll make total sense when I show you, okay? Just watch. It's going to make sense, total sense. No.
534? 5, 3, 4.
Are these same numbers?
No. No.
What are we missing in here?
0.
There's next to the 5th. There's next to the 5th. There's next to the 3rd, 2, 1. We're missing a place value of the x to the 4th. Just like in here, we'd be missing the place value of the thousands. So it goes x5, x4, x3, x2, x1. You've got to have it in there, right? Huh?
What's wrong about you? You were right.
So I could, if you don't want, I could rewrite it so you'll see it, but I mean, I could have rewritten this problem as, x minus 2 divided into 5x to the 4th plus 0x to the 4th. Yeah, so put a positive 2 down there. Yep, put a positive 2. Put your adder line, the remainder. Okay, see if you guys can do it. But you have to have the 0 there. You guys see that? If you're missing a term, fill it with the 0, okay? This is the place value.
Can you scoot the paper up a little bit?
Yeah.
You can see the whole thing.
You want to see the one?
Yeah.
It's not hard. If you can multiply and you can add, you can do this. Now, hopefully you can multiply and add because we are in algebra 2 by now, right?
So it goes back to 0, right? Yeah, it goes back to 0.
Yep. Oh, I just got another phone. I'm so
Sorry, I
lucky.
was looking at campus.
Were you?
Yes, I was really on it.
Oh, I saw you texted.
No, I opened on a text.
Okay, why don't you put it right there, huh? There you go, Leslie, let's do this, huh?
Wait, hey.
Take it away, I'll give it back to you.
Wait, is it
No,
not
I promise.
Yeah. Okay, Leslie, I won't even look at it. It's not there. Okay, so, okay, first step, what's our first step? Step 1, bring the 5 down, right? Bring the 5 down.
Mr. Davies, don't you get a 0 and then it's just 0 the rest of the time?
Okay, so there's no x to the 4th term, right? 5 times 2, got to multiply, is 10. And then you add. 0 plus 10 is 10. Multiply. 10 times 2 is 20. Then you add. 3 plus 20 is 23. Then we multiply. 23 times 4 is 46. Then we add. 4 plus 46 is 50.
Oh, I understand now. I did it, Mr. Davies.
50 times 2 is 100, right? Negative 4 plus 100 is a positive 96.
I understand now.
96 times 2 is, I don't know,
This makes sense now.
192.
I got
One
193.
Plus, yes, it's 193. That's my remainder. So my answer, 1 less power. Let's bring the x's back. So, bring the x's back. My answer is, okay, 1 less power, 5x to the 4th, plus 10x to the 3rd, plus 23x squared, plus 50x, plus 96, plus my remainder, which is 193 over x minus 2. That's the answer. If my remainder had been 0, I'd say it's a factor. Okay, so you guys can do this. So homework today is out of your journal. I'm going to have you do page 73, 5 through 8, and also on page 74, I'm going to have you do 13 through 17. 17 is the extra. Okay? Now, it's pretty easy, isn't it?